Hello everyone, welcome to another video for Mathematics of Grade 10. In this video, I decided to give you some more exercises and examples from the first section of Chapter 8, which was about solving right triangles. So we're just going to solve some of the questions that we have from this section, and let's see how it goes. Question number 1 says, solve the following right triangle. So remember, by solving a right triangle, you need to find all the missing sides and all the missing angles. So here in this triangle, I have angle A, I have angle C, but I don't have angle B, so I need to find this angle. I have the side length AC, but I don't have BC and I don't have AB, so I need to find these two side lengths as well. But let's first try to find angle B, because that is very easy for us at the moment. So to find angle B, all we have to do is to remember that if you add the angles in a triangle, the answer must be 180, right? So this one is 90, so the sum of A and B must be 90. Okay, so if A is 34, so B must be 56. So angle B equals 56 degrees. Okay, that was easy. Now let's find for example, side BC. Okay, let's find this one. I'm going to call BC little a, and I'm going to call hypotenuse little c. All right. So to find BC, I have to use trigonometric ratios. So let me write the definition of trig ratios here once more for you. Sine of A, sine of angle A equals opposite divided by hypotenuse. Cosine of angle A equals adjacent divided by hypotenuse. And tangent of angle A equals opposite divided by adjacent. So these were the trig ratios that we had before. So here in this example, if you want to find the length of BC, you have this side, which is next to this angle or adjacent, and that one is the opposite. Out of these three trig ratios, only one of them relates opposite to adjacent. Which one is it? It's tangent. So I need to use tangent ratio here. So tangent of 34 equals opposite, which is A, divided by adjacent, which is 8. And now you have to cross product. So A equals 8 times tangent of 34 degrees equals, and now here you have to use a calculator to get the answer of 5.39. So that's an approximate answer to the length of BC. To find the third side, which is the hypotenuse in this case, we have two options. Because I have AC and I have BC, I can use Pythagorean to find AB, right? Whenever you have two sides in a right triangle, to find the third side, you can always use Pythagorean Theorem. So that's the first option that we have, but we have another option. We can use one of these trig ratios to find the length of hypotenuse here, which I'm going to do here. I'm going to use one of these trig ratios to find the hypotenuse. So which one can I use here? Well, actually, in this case, I can use either sine A or cosine A, because I have these two sides, so it doesn't matter which one to choose. I'm going to go with sine A. So sine of angle A, sine 34 degrees equals opposite divided by hypotenuse. Opposite in this case is A, which is 5.39, divided by hypotenuse, which is C. So let's cross product. So C equals 5.39 divided by sine of 30 sine of 34 degrees. And now you have to use a calculator to get 9.64. So that's an approximate answer to the length of hypotenuse in this example. Next exercise, solve the following right triangle. Solve this one. So in this case, again, it is something like the previous example. We have two angles. We can easily find the third angle, and then we can use the trig ratios to find one of the sides and Pythagorean to find the other side. So let's find the angle first. What is the measure of angle B? Well, angle A plus angle B must be 90, right? So this one is 40, so that angle B must be 50 degrees. So that's the angle. Now let's find the sides. I'm going to show this side by B and that side, the hypotenuse, by C. Let's find side B first. So I have this angle, I have the opposite, and I want to find the adjacent. Again, just like the previous example, we can use tangent, because tangent relates opposite to adjacent. So tangent of 40 degrees equals opposite, which is 8.3, divided by B. So angle side B equals 8.3 divided by tangent of 40 equals, so you can use a calculator, and the answer is about 9.9. So that's the value of B. To find hypotenuse, again, you have two options. You can use either Pythagorean theorem, or you can use one of the trig ratios. I'm going to use a trig ratio. So I'm going to use, I can use either sine or cosine. I'm going to go with sine. So sine of angle A, which is 40 degrees, equals opposite divided by hypotenuse. So 8.3 divided by C. So again, a cross product, C equals 8.3 divided by sine of 40, which is equal to about 12.9. So, and that's the value of the, that's the measure of hypotenuse here in this case. So, and that's it. We did solve this right triangle here. We found all the angles, and we found all the sides here. Next example, another question solving the right triangle. In this case, we have two sides and only one angle. So two sides, only one angle. Well, I can easily find the hypotenuse in this case by using Pythagorean theorem. And then I can use trig ratios to find the angles. Okay, so let's find the hypotenuse first by using Pythagorean. I'm going to call this one C. So C squared equals 6.2 squared plus 4.1 squared. C squared equals, so 6.2 squared is 38.44 plus, and 4.1 squared is 16.81. Okay, so now we should add them, and that is 55.25. So therefore, C equals the square root of this number, which is about 7.43. So, and that's the approximate answer for the hypotenuse length. All right, so we found the hypotenuse. Now it remains to find the angles. Let's deal with angle A first. I have all the sides here. I have this one, and that one. So there's no difference which trig ratio I use. I can use either sine, cosine, or tangent to find the angle A. So let's go with sine. Sine of angle A equals opposite over hypotenuse. In this case, opposite is 4.1 divided by, and hypotenuse is the number that we just got here, 7.43, and that is equal to 0.55. Now we are looking for an angle. Okay, we are looking for an angle whose sine is this number, 0.55. In order to recover the angle, we use an operation which is called sine inverse operation. So on your calculators, usually on the top of sine button, you will see something like this, sine raised to the -1. Well, actually, this is the inverse function for sine. So that's the sine inverse function which we have to use here to find the angle A. So whenever you have sine of an angle, to find the angle itself, we'll use the sine inverse operation. Maybe on your calculator you have to press shift and then sine, or maybe alpha and then sine. Depending on your calculator, you can easily find this operation. So angle A equals sine inverse of this number, 0.55. Okay, so just remember, always whenever you have sine of an angle and you want to find the angle itself, use sine inverse operation. Or if you have cosine of A and you want to find A, use cosine inverse or tangent inverse. They're all the same. Alright, so if you use your calculator, you will see that sine inverse of 0.55 is about 33.5, and that's the approximate value of angle A. Alright, so we have angle A, which is 33.5. We have angle C, which is 90, and remains to find angle B. So in this case, again, we have several options here. We can use trig ratios for angle B, maybe sine, cosine, tangent, doesn't matter. You can use any one of them to find angle B, and again, you have to use inverse operation. But there is a much easier way. You know that you have, if you have a triangle, the angles must add up to 180. So you have two angles. To find the third angle, we should add these two and then subtract it from 180. So angle B equals 180 minus the sum of those two angles, 90 plus 33.5, which is equal to 56.5. And that's the value of angle, that's the measure of angle B.